This video is a continuation of the unit on atomic structure and will look at ions and isotopes. The Virginia SOLs that are related to this topic are listed below in the video. Okay, let's get started. We will begin this video by looking at ions. Anytime an element has the same number of protons and electrons, it is referred to as an atom. But when an element starts to gain or lose electrons, it is no longer called an atom, but now it is referred to as an ion. The value of the ion charge will always be equal to the number of electrons that have been lost or gained by the element. So there are two types of ions. So cations are the first type that we'll look at. A cation is formed when your atom loses electrons. The example illustrated is the sodium ion, which has a 1+ charge. Now, this ion has 11 protons, and we've learned earlier that the number of protons or the atomic number will determine the identity of the element. So, the element that has 11 protons is sodium. We also recognize that the number of protons and the number of electrons are not the same, so it cannot be an atom. Because there are more protons than electrons, the overall charge for this ion is positive. The value of this charge is 1 because we have one more proton than electrons. Elements that are metals tend to lose electrons and form cations. The second type of ion would be an anion. Anions are formed when an atom gains electrons. Oxygen, or the oxide ion, is our example of an anion. Here it has 8 protons and 10 electrons. So the 8 protons helps us to identify the chemical symbol is O for oxygen. Remember, oxygen is the only element on the periodic table with an atomic number of 8, or it is the only element that has 8 protons. If you compare the number of protons to the number of electrons, there are 2 more electrons than protons. Because electrons have a negative charge and there are 2 more electrons than protons, the overall charge of this ion is 2 negative. Elements that are nonmetals tend to gain the electrons and form anions. Another way of determining the charge for an ion is by using this equation. You will always subtract the number of electrons from the number of protons. This is an image of a periodic table, and the boxes that have been shaded this blue-green color represent those elements that are metals, and they will form cations. The boxes that have this orangey brown shading are those elements that are nonmetals, and they will form anions. The red line or staircase is used to separate your metals from your nonmetals. So let's summarize this topic, ions. When the number of protons and electrons are the same, the element you are dealing with is classified as an atom. When the number of protons is greater than the number of electrons, then the overall charge of the ion will be positive, and the value of this charge is equal to the number of electrons that have been lost. However, when the number of protons is less than the number of electrons, the overall charge of the ions would be negative. The value of that charge is also going to be equal, but it will be equal to the number of electrons that have been gained. So let's put this into practice. So let's do some practice problems. While we work these problems out, you might want to keep this formula, which we displayed earlier, close by. So the first problem is, what is the chemical symbol for the ion with 13 protons and 10 electrons? Well, first thing you're going to want to do is find out the identity of the element. Remember from the previous lessons that the protons determines the element's identity. So look at your periodic table, find the element that has 13 protons or an atomic number of 13. That element is aluminum. So the chemical symbol for this ion would be Al. Now, since the number of protons and electrons are not the same, we know we're dealing with an ion. We need to figure out what is the charge of the ion. If you would subtract the number of protons, 13, from the number of electrons, 10, the difference would be a +3 charge, letting me know the charge of this ion is +3 or 3+. So this would be the chemical symbol for this particular ion. Another way of solving this problem without doing the math is by comparing the number of protons to the number of electrons. We have 3 more protons, which are positively charged, than electrons, which are negatively charged. Because there are 3 more protons than electrons, and protons are positively charged, the overall charge of this ion would be 3 positive. Let's look at another problem. This problem reads, what is the chemical symbol for the ion with 7 protons and 10 electrons? Well, again, first thing we want to do is figure out the symbol for the element, and we're going to look at the number of protons, which is also the atomic number for that element. On your periodic table, the element that has atomic number of 7 is nitrogen. So the chemical symbol for this ion is N. Now we know it's an ion because the number of protons and the number of electrons are not the same. So to figure out the charge for the ion, you would subtract the number of protons, 7, from the number of electrons, 10, and the difference would be -3. The charge for this ion is -3. Another way of solving this problem without doing the math is just by comparing the number of electrons to the number of protons. In this particular problem, we have 3 more electrons than protons. Because electrons carry a negative charge, that means the overall charge of this ion is going to be negative, and the value is 3 because there's 3 more electrons than there are protons. So let's try this problem in reverse. In problem 3, we're asking how many protons and electrons are present in an iron 2+ ion. To figure this out, first thing you're going to want to do is find iron on the periodic table. Once you find iron on the periodic table, look at its atomic number. Remember, the atomic number tells you the number of protons. Iron has an atomic number of 26, meaning it's going to have 26 protons. However, because of the 2+ charge, we know the number of electrons are not the same. To figure out the number of electrons, you can plug the known information into the equation above. We know the charge is 2+, and we know we have 26 protons. We could then solve for our unknown variable, the number of electrons. If we use this equation, we find out that the number of electrons is 24. You could also figure out the number of electrons by realizing because this ion has a 2+ charge, that means we have 2 more protons than electrons. Here, you can see that you have 2 more protons than we have electrons. Let's look at one final practice problem. It reads, how many protons and electrons are present in the bromide ion? Again, to determine the number of protons, I would look at my periodic table and determine the atomic number for bromine. It has atomic number of 35, meaning you have 35 protons. To determine the number of electrons, you can substitute the known information into this equation. We have a charge of 1 negative, we have 35 protons, and we're looking for the number of electrons. When we solve for x, the number of electrons would be 36. You can also keep in mind that since this ion has a 1 negative charge, we are saying that we have 1 more electron than the total number of protons. 36 electrons is 1 more electron than the total number of protons. We will get some more practice with this concept when you return to class. Let's continue on with the second half of this video and let's look at isotopes. Isotope means you have the same number of protons but a different number of neutrons. As the number of neutrons changes, so does the mass number for that isotope. Each isotope of the element has a unique mass number. Isotopes of the same element are chemically alike because they all have the same number of protons and electrons. And the protons and electrons are going to determine the actual behavior for that element. So although the mass number may change, or although the number of neutrons changes, it does not have an effect on the chemical behavior for that element. So let's take a look at the word mass number. Remember, majority of the atom's mass is in the nucleus. The total number of protons and neutrons in an isotope is referred to as the isotope's mass number. It is unique for that particular isotope. To identify an isotope more specifically, a chemist will add the isotope's mass number after the element name. This is a great example of how that can be done. Here we have the element name hydrogen, and then we have the mass number for this particular isotope being written after the name, separated by a dash. This is an example of an isotope. These are the 3 hydrogen isotopes. All 3 hydrogen isotopes have 1 electron, and they also have 1 proton. However, they each have a different number of neutrons. The hydrogen isotope has 0 neutrons. Deuterium isotope has 1 neutron, and the tritium isotope has 2 neutrons. This is another example of an isotope. Here we have carbon's 3 isotopes. There's carbon 12, carbon 13, and carbon 14. Again, these 3 isotopes have the same number of protons and the same number of electrons. The only difference in these 3 isotopes is the number of neutrons. Another shorthand way of writing the formula for an isotope, you would first start out by drawing the element's symbol. You would then place the atom's mass number to the upper left of the element symbol, and the atomic number would be written to the lower left of the element symbol. This would be the shorthand notation for the hydrogen isotope called deuterium. So let's do some practice problems with our isotopes. But I'm going to add a little twist to this problem. We're going to add a charge. When you are given a symbol such as this, you could be asked to determine the number of protons, electrons, and neutrons present in the isotope. In order to do that, you've got to keep in mind what each of these terms, mass number, atomic number, and charge, mean. So to determine the number of protons, I would just look at my atomic number because the atomic number tells you the number of protons. So for this isotope, we have 28 protons. If I'm trying to calculate the number of neutrons, I would subtract my atomic number from my mass number. So when 28 is subtracted from 59, you have 31 neutrons. Next, we need to determine the number of electrons. Because we have a charge, we know the number of electrons are not the same as the number of protons. Now, because we have a charge, we know it's an ion. To determine the number of electrons, you're going to have to do one of two equations. If your charge is positive, like in this example, you will take the atomic number and you will subtract the charge from it. But if the charge is negative, you will add the charge value to the atomic number. Since our charge is positive, we're going to subtract the charge value from the atomic number. When we do that, our number of electrons is 26. Let's look at another problem. Here we have the symbol for this isotope of selenium. The mass number, atomic number, and charge have been provided. The problem says, what would be the number of protons, electrons, and neutrons for this isotope? Remember, to determine the number of protons, that is going to be equal to your atomic number. So since my atomic number is 32, the number of protons we have is 32. To determine your number of neutrons, it would be your mass number minus your atomic number. My mass number is 79 minus the atomic number of 32. The number of neutrons would be 47. Again, because this particular isotope has a charge, the number of protons and electrons are not the same. So we have to look at the type of charge to determine whether or not we're going to be adding or subtracting the charge value. Again, if the charge is positive, you would subtract the charge value from the atomic number. But if the charge is negative, as in this case, you're going to add the charge value to the atomic number. When the charge is added to the atomic number, we see we have 34 electrons. When I ask you to determine the complete chemical symbol for an isotope, we're asking you to create a mass number. When you're asked to determine the complete chemical symbol for an isotope, you're being asked to determine the mass number, atomic number, chemical element symbol, and the charge when appropriate for that particular isotope. So we're going to use the information provided in this problem, and we're going to determine what is the symbol for the isotope. The first thing you're going to do is figure out the symbol for your element, which will be equal to your number of protons. This particular isotope has 40 protons. Looking on the periodic table, I would find the element that has an atomic number of 40, which also means it has 40 protons. That element's chemical symbol is Zr, also known as zirconium. So the first part of the isotope's symbol would be Zr. Next, I need to figure out what is this isotope's mass number. The mass number will be determined by adding the protons and neutrons together. This isotope has 40 protons, 51 neutrons, so the mass number is 91. The mass number will be written to the upper left of the chemical or element symbol. Next, we want to know what is the atomic number. Remember, your atomic number is always equal to the number of protons. Since this isotope has 40 protons, my atomic number will also be 40. And it is always written to the lower left-hand side of the chemical symbol for your isotope. Finally, I notice that the number of protons is not equal to the number of electrons, so I know I have a charge. So to figure out the charge for this isotope, I will subtract the number of electrons from the number of protons. In this isotope, you have 36 electrons subtracted from 40 protons for a difference of a 4 plus charge. This would be the correct chemical symbol for your isotope for this problem. Problem number 4, we're being asked again to determine the complete chemical symbol for an isotope. It has 54 electrons, 74 neutrons, and 53 protons. And the first thing we want to do is figure out the symbol for this isotope. Remember, the element symbol will be equal to the number of protons. This isotope has 53 protons. Looking on your periodic table, find the element that has an atomic number of 53. That would be iodine. The chemical symbol for iodine is a capital I. So that would be the first part of the chemical symbol for my isotope. Next, we want to calculate the mass number, which is determined by adding your protons and neutrons. This isotope has 53 protons and 74 neutrons for a total of 127 as the mass number. The atomic number will be equal to the number of protons. This isotope has 53 protons, so the atomic number is going to be 53. Also, you should notice that the number of protons and the number of electrons are not equal. Therefore, this isotope will have a charge. To calculate the charge, you will subtract your electron numbers from your protons. This isotope has 54 electrons subtracted from 53 protons gives it a charge of 1 negative. This would be the complete chemical symbol for this isotope. So this concludes this video on the atomic structure of ions and isotopes. We will do additional practice problems for both of these concepts in class. I'll see you then.